Sorry for that loud beginning. Welcome back. We are halfway through week 2 of our fractions. Today, we are going to be talking about something that you have talked about in other contexts, and we have talked about in other contexts, but we're going to use it for fractions now. Get excited. We're talking about number lines today. Now, we have talked about number lines. What we have said before, we've talked about lines being something that stretches on forever in both directions. Okay, these arrows that we put at the edge of the line tell us that this line will never stop when it goes this direction. It just keeps going. This arrow tells us that it just keeps going on forever in this direction. Now, I've shown you guys online the zoomable number line. So there are no correct numbers to put on this number line. That used to stress me out as a kid in school. I always was like, which numbers am I supposed to put? And the truth is, it doesn't really matter what numbers we put on the number line. Our goal is to find the numbers that are going to be the most helpful for us to use on this number line. Okay, so if we were using this to, I don't know, add maybe, we would want to start with whatever number it is that we're adding, and then we might draw something that is in a particular range, like if we did 50 plus 70, we would want to start somewhere around 50. And this line represents that to the left of this, we have 40 and 30 and 20 and 10 and 0, and honestly into the negatives. And then we have all the things that come next. But if we have plus 70, we could break this up however we want. We could think of 70 as 7 tens, and we can do plus 10, plus 10, plus 10, plus 10, plus 10, so we would want to make sure we had room for that. Or we could break this into 50 and 20. We could do 25 and another 25, and then a 20. We can do whatever we want. It doesn't matter. It's whatever is the most efficient. Or we could just do 70, 50 plus 70, and move it up if we know the answer. Now, the answer to 50 plus 70 is 120. So we wouldn't want to put right here like 8,000, right? Because these are nowhere near each other. If we did this, then 120 is going to be like right here. Doesn't make sense, okay? So whenever we're using number lines, we do want them to make sense. But also remember that if I take a number line, let's say between 0 and 100, and I have halfway between that, I have 1, 2, 3, 4, 5. Whoop, oh, I messed up. Let me do that once again. Remember, every partition we put, it adds an extra part. So I've got half. So if I want 5 right here, if I want this to be 50, and I'm going by tens, I want 10, 20, 30, 40, 50, 60, 70, 80, 90. I only want 4 partitions between 0 and 50 and 4 partitions between 50 and 100 for a total of 10. Now, each of these, the way that I've drawn this, I have intervals of 10. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. But what we've got to remember is that between each of these, there are 10 tiny ones. So we could cut this in half. 1, 2, 3, 4. 1, 2, 3, 4. And if we zoom in to that, we have 40 over here, and we have 50 over here. And then between that, we've got 45, we got 41, 42, 43, 44, 45, 46, 47, 48, 49, and then 50. Okay, so if I wanted to, show 44, it's right there, 44. Zoom out, 44 is somewhere around here. If we zoomed out even further to like 0 to 1,000, it's going to be over here closer to 0. Anyway, what we're getting at today, we can even zoom in between these. Okay, so say between 44 and 45, there are 10 little notches. Now, I don't really want to work between 40 and 50, or 44 and 45. I want to work between 0 and 1. Because remember, fractions are parts of a whole. Okay, so if I take one whole, back to our manipulatives, it's like this is the number line. This is 0, this is 1. Okay, there are no partitions between here. We're just looking at one hole. But if I cut down the center of this, I have 1/2. I can get my manipulatives. Big long word. Okay, see? This is 0 to 1/2. This is 1/2 to 1 hole. 0 to 1/2, 1/2 to 1 hole. So if I wanted to plot 1/2 on the number line, I could plot it right there. But what if I wanted to plot 3/4? Well, I could cut each of these halves in half. And I could have 1/4, 1/2, which is equivalent to 2/4. 3/4 is going to be halfway between those. And then we have 1 whole, which is the same as 4/4. Here are my fourths. So remember, 1/2 is the same as 2/4. So 1/4, 2/4, same as 1/2. Then 3/4 halfway between that. And then if I have a 4/4, which I cannot find at the moment, it would stretch out and equal exactly 1 whole. And we can do the same thing with thirds and all those things. But remember that thirds, they don't quite line up with these. They don't quite line up with fourths. They're going to be somewhere just to the right of the fourth. So it's going to be a little bit bigger than 1/4, maybe around there, and a little bit less than 3/4 for 2/3. But then 3/3 will be right here. 1 whole can also be the same as 2 halves, or 5/5, or 6/6, 8/8, 10/10, 12/12, 100 hundredths, and so on. But the ultimate idea with using the number line for fractions that we're trying to get to is cut it how you need it. This is literally just this. But instead of us shading something in, we plot a point. Okay? If I want 1/2, I put a half there. If I want 1/2 here, I put a partition down the middle, and then I shade 1/2. If I want fourths, I split each of these. I split each of these. If I want eighths, I split each of these. Split each of those. Okay? And we could keep going to 16ths or whatever we want. But that's number lines for fractions. It's going to be always between 0 and 1 as long as we're dealing with proper fractions. We'll get into something later called improper fractions, but don't worry about those just yet. Today, you're going to be given a sheet, something like this. It says empty fraction number lines 0 to 1. Okay, 0 to 1 is going to apply to every single one of these. So when you get this paper, I would recommend that you go ahead and just label your 0 and your 1 for every single one of these. Remember, all the holes are going to be the same exact size. 0 to 1, 0 to 1, 0 to 1. But now you have partitions, just like we do with our area models, with our fraction bars, whatever. I want you guys to label each of these according to what it is. So if we have a hole that's split into 2 equal parts, how far from 0 is this part? Right, 1/2. So you would label that as 1/2. Okay, now this one, we've got this area from here to here, we've got this area from here to here, we've got this area from here to here. And they're shown with a little tick mark. So that's 1 step, 2 steps, 3 steps. So 3 steps from 0. And yeah, we can think about this as steps as well. So 1 step from 0. Remember, you don't label this as 1. This is 1 step. And this is another step. Here we have 1 step, 2 steps, 3 steps. So that's 1 step, 2 steps, 3 steps. How many steps? 3 steps to make a hole. So this one is called 1/3. This is 2/3. And this is 1 whole, or 3/3. And this can be 2 halves. So go through all of these and fill those out. And once you've done that, you're going to use it to compare. Okay, we're back. We're still comparing. But we're going to compare with a number line. So let's look at this one. 4/6 versus 12/12. Well, I want to find the one that has sixths. Let's see. We have 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. So these must be our sixths. All right, so I'm going to label them 1 6, 2 6, 3 6, 4 6, 5 6, and 1 whole or 6 6. Notice that 3 6 also lines up with some other things. It lines up with this one right here. It lines up with this one right here. It lines up with this one, and this one. There's a lot of equivalent fractions to 3 6 or 1/2 or whatever these other ones are. 2 6 lines up with this one. It lines up with 1/3. It lines up with this one. 5 6 only lines up with this one. Okay, so some of these have more equivalent fractions on the page. Some have less. But anyway, we are comparing 4 6 to 12 12. So I'm going to start by plotting 4 6. So we have 1 6, 2 6, 3 6, 4 6. I'm going to plot a point directly on the number line. There's a lot of you guys that like putting it like this, and it looks like a little spider hanging down from a web. That is not what we want to do. Okay, we want the spider to be right here, right there, on the line, not beneath it. So on the line. So that's 4 6, and we want 12 12s. Well, let's see if this is 12. So I'm going to assume it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. That's our 12s. Well, I have 1 12, 2 12s. You guys are going to need to label this, but I'm trying to make this video not take the whole day. 1 12, 2 12s, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 12s. So 1 whole is the same as 12 12s. And I'm going to plot a point there. Remember, not a spider hanging down from the little line. But now let's compare left to right. Which of these is the furthest away from 0 if we take our jumps? Okay, is 4 6 further away from 0, or is 12 12ths further away from 0? If we start at 0 and go this way, have we reached 12 12ths? We have not. I mean, we have not. We have reached 4 6. We have not reached 12 12ths. If we start on this one, we hit 4 6 before we ever do 12 12. So then 4 6 is going to be less than 12 12s. Any of these that are close, that are closer to 1 or further to the right on a number line are going to be greater. Just like if we thought of these as an area model, like we did earlier. We've got our sixths. This would be shaded all the way to here. And this would be shaded, whole thing would be shaded. It'd be split into 12 parts, but the whole thing would be shaded. So this one is going to have more, and this one would be less. I want you guys to do that same thing. Don't do all this extra. You don't have to do the lines like this, but I do want you to label the parts. So 0 should be labeled, 1 should be labeled everywhere, then 1/2, 1/3, 2/3, 1, etc. Label all the fractions for me and then use them. You can plot the points if you'd like, but make sure you're using a pencil so you can erase it. And then when you find which one is largest, use that to place the correct comparison symbol in the box. Once again, good luck. Looking forward to seeing you guys again. Do your best, and I'll talk to you tomorrow.